Hello and welcome to this discussion on managing, counting and measuring the performance of the IT related workforce in the organization. Today, because a lot of companies are in the space of software development or could have been on a large scale digitized, it becomes important to have the right metrics for evaluating their performance in such a way that you not only do justice to the evaluation process but also find out exactly what causes performance delays and how do you find out the right performance. So this is going to be a nice and important session. I hope you bear with me through it, and I'm surely going to share some useful insights with you. And do not forget to please share and subscribe and let us know how you're finding our content. Some related content would always have been already created, like say for example on performance, on culture. I've already created content which you can look up into our channel and find them. With this, let's quickly begin. So why have I begun by saying convert problems into tasks? Let's understand this. Look, as I talk to my students and when I advise other people also, I say that whenever you're trying to attempt something, one good way to begin is to understand or devise the philosophy behind what you want to achieve or attempt. Why? Because when you look at it from the lens of philosophy or the lens of the meaning that it delivers to life, and that's what I consider philosophy is all about. It is about the meaning behind life. So when there's a problem and you want to attempt it, or when you want to do something about anything in life, if you have a philosophy in front of you, it's like the guiding pole or the guiding stick which can help you understand which path should you take, because there are always multiple paths. I never say that there's only one single solution, just like there's no one single truth. So there are not one single solutions. There are multiple solutions because there are multiple perspectives. You can look at things from multiple ways. My attempt here would be to look at it from one of the ways, of the multiple ways, probably advised, practiced by very big companies, and hence my suggestion and my request that you should also follow the same path. So when I begin with these four aspects of philosophy, that's where the whole core of performance management measurement lies. Convert, manage, clarify and qualify. So there are the four steps that you should look at whenever you are doing performance management. And how do we do it? Well, this is how we do it. So when I say convert, I mean convert problems into tasks. Now, this again is a philosophical statement, basically that problems will always occur. What you need to do is look at problems and figure out, okay, what are the tasks that can help me achieve the problem, or if the problem has caused about a loss or some kind of damage, how do I ensure what task should I perform so that I don't face a similar problem or damage later. Or the fact that if you break down problems into smaller pieces and then solve them each one task at a time, you will be able to bring about a big amount of change and do a lot of improvement. So I hope that becomes clear as a philosophy, that if you convert your problems into tasks, you will see things become much more easier. A great example could be uh, how the Indian team is winning this year. It's I believe that how they are winning is that they are converting each of the problems or the hurdles in the game into smaller tasks, and then within those tasks are roles played by the particular batsman or the particular bowler and the fielder, um, so that the team together looks well gelled. After all, at the end of the day, it is all individual performance which appears as a collective effort because they're aimed at the same direction. So that brings us to the second one, which is manage, count, and measure before you act. So rather than rushing about just picking up something, understand, then first devise the philosophy, uh, break it down into tasks, count them, measure them, so that you can manage them before you jump into action. And this is particularly important for youngsters. I find a lot of youngsters jumping into tools, not understanding that tools are not the technology. Please, please, please remember this. Tools are the means, right? Outcomes are what you want. We'll come to that at the end, so that you'll understand that piece also. Then clarify information to avoid structural collapse. What happens is often there are subsets of information which flow to us, and we often feel that because this task or this part of the problem is not required to be shared with others, purely because it does not uh, that person has no role to play with it. No, if you consider that you are into a team effort, you are into a team game, you are operating as a team, then it's important that the information is shared equally and at the same time across the team. If not, what could happen is that some team member who has not been shared the information, or a team which is working parallelly in, say, deployment of a software, will work in a different manner. To understand this in great length, I would suggest to look at Conway's law, a very famous finding that organization structures get naturally distributed, or naturally the architecture of the organization structure gets designed not by the hierarchy but by the communication flow. So that's again a topic for another day. The fourth point is qualify the outcome, not the output. Now let me here make the difference so that you really understand the subtlety of this message of this philosophy. When I say qualify the outcome and not the output, your output is in the term of a certain product that you have delivered, a certain design that you have created, a certain service that you have materialized, but that is the output. The outcome is when someone uses it and benefits from it, like when the client uses the product. And that's where often that measurement gets skipped, or that measurement is never measured at the individual level of the developer, especially for software, as we are discussing software companies and software workforce performance here. So hence it's important that you qualify the outcomes. The output could be anything. The output could be actually 200 lines of code, but what you could require is probably 20 lines of code, right? The point becomes, what happens to the outcome of those 200 lines of code? Do they make it difficult when you once you have committed it, once you have built it into the what we know as the trunk, or does it contain certain wrong codes leading to a technical debt and then a lot of rework? So these are very important hints to be looked at to understand basically that when you're measuring performance, it's important to measure it from the outcome perspective rather than from the output perspective. Like someone could have scored 100 runs and yet it would have been done in such a slow pace that it only benefited the individual uh, batter but not the team per se. So I hope you get clarity on this. So why are we talking about all of this before we talk about performance and team dynamics? Look at this statement by Google. Google wanted to discover if there were any common factors among its best performing teams. They started a 2-year research project to investigate what made Google teams effective, conducted 200 plus interviews with employees and looking at more than 250 attributes of 150 plus active Google teams in 2015. They expected to find a combination of individual traits and skills that would be the key ingredients of determining what are high performance teams. What they found instead was that who is on a team matters less than how the team members interact, structure their work, and view their contributions. In other words, it all comes down to team dynamics. What you find here in this quote I found by an author in his book called Accelerate was that they had done years of research, and even Google found that performance is not always a product of simple individual efforts. It is, of course, individual efforts, but when you are looking at teams who are delivering, it's important to look at how they are structured, how do they communicate, and hence how efficient they are when it comes to code commitment and continuous deployment, as is famous nowadays. So let's look at a standard team first. So if you look at a standard team, it could be doing certain complex tasks, it could be doing certain maintenance tasks, it could be doing testing and reworking tasks. Now typically if you have a single team which is into everything, what happens is that there is sometimes a communication overflow, and what you end up then creating as an outcome, as a software, becomes a large monolith where it's very difficult to understand, or it's difficult to track through. Like they say, the hardest thing for developers is to look at someone else's code and find out the source of errors and problems. So the more you break it down, the more you simplify it. So how do you do that? Okay, one of the ways is to look at a team structure like this. You have a set of people dedicated to complex tasks who could communicate in turn with the testing team, and then there could be a separate team of maintenance tasks and people who have been tasked for reworking tasks, or the same team sometimes, of course, could be working on its own task and hence communicating between themselves. What it tells you is that one, it highlights both the capabilities within the team. It also tells you how do you distribute work in an efficient manner so that you ensure that people are delivering based on their capabilities and also their own team dynamics. Like some people would really love to be doing the testing work, some people would love to do maintenance work, some could be more potent in handling complex tasks. In fact, the study which I mentioned found that in new work, the difference between performance and laggards was almost 11%. In rework, it was around 6%, and in other work, which could include even designing meetings, other stuff that they need to do, around 5% of difference. which means that they were doing other tasks less, they were doing rework less compared to, and hence they were delivering more of new work. They were committing to their codes faster. So a good programmer should have these qualities. A good developer should be able to uh, deliver new work faster. Here's the key. So how hence can we measure them? What are the metrics that are determinant of this? Studies have shown that the four factors of lead time, release frequency, change fail rate, and the mean time to recovery, which is MTTR, are the most important four factors to measure when you are trying to look at measuring performance of coders and programmers. What are these? So how do you measure? Typically, the scales should be kept at right from 1 hour to probably 1 month. Certain tasks could require 1 hour, certain 1 day, certain 1 week, and certain of them probably 1 month. Sometimes complex tasks could even take up to 3 to 4 months or even 6 months based on how large the project is. But the typical advice always is, and if you go back and see my videos on performance and OKRs, is to limit any task to maximum 2 to 4 weeks and not more than that, because the more you make it shorter and crisper, the better you get a handle on exactly what's going wrong, what fits well within the capabilities of the team, and hence what could be the delivery optimum size. So what basically is lead time? Lead time is basically the time taken from the client requirements to the pushing of the codes into production, or what you would call as delivering of the instance. Now here again you would have often two components. One of them is the design or the prototyping of it, which often could take a lot more time. That how do we deliver this? This is the requirement of the client. The client requires that you should help us in designing a platform to measure performance. So what are the components? What are the attributes that you are going to measure? How are you going to measure it? What are going to be the metrics? How is it going to be designed? Which all buttons would you put? Those become part of course, the designing part of it, the prototyping of the software. I personally believe that you should be measuring it once the prototyping is done, and then, so which means you leave that to they are basically more meeting related time spent compared to actual coding. Actual coding becomes once the prototyping is done, it has been sorted and settled, the client has given the go ahead, and hence you start your lines of code. Now so the lead time is the time taken from the start of the coding to the convert of the code into production. Now within that you have the mean time to recovery, or the MTTR. MTTR basically is useful when there is a problem, or there's an error and you need to fix that bug. So how quickly can you fix it? So that's basically the mean time required to resolve a problem. Now because there are often bugs in the software, which basically tells you that exactly how well you had coded in the first instance, so that you can identify. Now one of the rules is of course suggested to be sandboxing, that if you can sandbox your codes in such a way that you keep it loosely coupled, the architecture, so that you can quickly go back and find out at where the bug exactly is sitting, so that you take lesser time to resolve or recover. The second is the release frequency. Now as I was already mentioning earlier, that it basically, how often do you release is based on the confidence and the rhythm that the team has delivered, and hence the time should be decided or based on what they do well. Do they do well if they are given to complete a task within 2 weeks, and do they feel fatigued if it stretches beyond 2 weeks? So you understand that what is the rhythm, because what happens is that every time you create a set of codes, right, you put it into testing, you then push it into production. When you push it into production, it's called as alignment with the trunk. So it's like a big tree. So when you're designing a tree or you're building a tree, you create new branches of codes, and those new branches get aligned with the trunk, which means that now they are committed. In the process, if you make mistakes, those mistakes are known as technical debts, because what happens is you'll have to go back and redo them. And hence, it's important to understand the team's attention span. How much attention does the team have? And that can help you to design or devise which tasks should be handed over to which teams. Which teams would do better in a 4-week for a 4-week task versus which time would do better in a 2-week task. Now you understand that the 4 key metrics to measure for developers and programmers are the lead time, the release frequency, the MTTR, and sometimes the change fail rate. Now, what is basically the change fail rate? So often what happens is that when we make changes to the software, those changes actually fail. What it tells us is that how efficient we are as programmers. So it has a great bearability on, of course, the knowledge. Sometimes if you have to make changes to the programs, those changes do not come out, or making a change in one place results in a bug creeping out at some other point because of the relationship. So again, that's where the sandboxing helps. But good programmers have been found to have lesser change fail rate compared to laggards. So that could be a good indicator of how well someone's codes are. See, the optimum is, of course, not to make it so difficult that while it's a code is great, but no one else can read it, no one else can decipher it. No, it should not be so tough also. It should be simple enough, and yet it should also be optimized to ensure that what can be done in 20 lines does not require you to deliver 200 lines of code. So what's the mantra? Hence, how should you model? Of course, you should take in these 4 factors. One important thing to look here, and what studies have proved over time, is that there's a particular performance culture around these teams, and you need to encourage that culture. So how do you encourage that culture? How do you ensure that they are engaged also? Because performance cannot be held in isolation. Every performance as an event leads to productivity, or it leads to profitability. So one of the good practices has been that if you allow teams to use their own tools, sometimes the limitation that no, you should not use Scrum here, you should not use Jira here, you cannot use MongoDB here, limits the capability performance of certain people, and hence either you prioritize the tools required by seeing that the same kind of tools everyone is comfortable within the team using those same set of tools, or you allow them to use whatever tools they are comfortable with, as long as it can deliver the right codes. If you have noticed, there's the famous Grok Elon Musk has been talking about on X, and it's a creation of SourceGraph, and they are people who are even trying to help simplify the process of coding, and in fact they have a product called Cody which helps you to do that. Basically it's an artificial intelligence in coding. The second is that good performers have been found to have higher levels of software delivery performance, which is that they are faster and whatever they deliver has better outcomes for their clients. How do we know that? They have shorter lead times, their deployment frequency is higher, their time to restore services, their MTTR is lower, and they also have a lower change fail rate. Finally, one thing could be that because people are engineers, because coders are engineers, they are often not creative. Please understand that it's not that actually there's too much of creativity. People have just been doing incremental developments over past products. MapQuest led to Google Maps. So there are a lot of old products on which new products have been built. So someone had done some of the work and then someone else has taken and put up some incremental measures to make it finer, smoother, better. So always remember, all ideas are incremental. That idea must have been somewhere. What you need is those sharp capabilities to observe and know those ideas exist, and hence to pick them up and allow them, because the more you are externalized, the more you are better in terms of delivering, because you don't need to create from scratch. You don't need to reinvent the wheel. And finally, developing a generative performance-oriented culture. Here, a good mention could be looking at Winstrow's organization culture framework, where basically if you have a collaborative culture, if you have a culture where teams are decided and teams are created based on communication flow, you will find a much healthier, faster outcome and satisfaction and growth for the organization in general. I hope these have helped you. If you are interested and if I have a good amount of shares and likes, I'm surely going to expand on these topics, of course based on also requests from our patrons, our subscribers. So do let us know what you want to hear about, and understand that these are all not theories, but these are how you actually practically implement things, because in theory things might look a little different, though I don't believe that theory is unimportant. It is equally important. You should know the theory, because if you don't know the theory, often you might miss out on certain things. So again, that measure, count, manage before you act implies that you have done your measures properly, you have understood everything that you're going to deliver. With this, I would like to thank you for your support, and I look forward to seeing you again. I hope you have a nice day.